Okay, so yesterday we talked about the slope and rate of change. Today we're going to talk about direct variation, and we're going to write and graph an equation of direct variation. A linear function defined by an equation of the form y equals k times x, or if you rewrite it and solve for k, you get y over x equals k. And since where k is not equal to 0 represents a direct variation. Okay, so anything that's written in the form y equals k times x, where k is not equal to 0, represents a direct variation. The formula, when we write it and solve for k, y over x equals k, says that except for the point 0, 0, the ratio of all output-input pairs equals the constant k. So remember, input, output, your input is usually your x variable and your output your y variable. When you do y divided by x, that represents your constant k, which is a constant of variation. Okay, so for the following function, determine whether y varies directly with x. If so, find the constant of variation and write the function rule. So remember, the formula for direct variation equals y equals k times x. Remember, it's y equals k times x. Alright, so what we need to do is we need to find out what we're multiplying to our x variable, since k is our constant, right? Since k is our constant here, we need to figure out what number we're multiplying to my x variable every time in order to obtain the y in my table. Does everybody see that? Okay, so this is where you need to think to yourself, what do you multiply to 27 to get 9? What do you multiply to 30 to get 10? What do you multiply to 60 to get 20? Okay, or what do you divide 27 by to get 9? Or what do you divide 30 by to get 10? Or what do you divide 60 by to get 20? Okay, the number that you divide each one of these by is 3. So remember, when you divide by 3, you're really multiplying each number by the fraction 1/3, right? So we're multiplying 27 times 1/3 to equal 9. Multiply 30 times 1/3 to equal 10. And you multiply 60 times 1/3 to equal 20. Does everybody see that? So here, my constant that I'm multiplying to my x variable is 1/3. So to answer our question, for the following function, determine whether y varies directly with x. Do we have the same constant we're multiplying to the x variable? Yes. So yes, it does vary directly with x. So if it does, find the constant of variation and write the function rule. So since we're multiplying 1/3 each time, we know that my constant of variation is going to be equal to k, my constant is 1/3. Okay, so if I write the function rule, we know that the direct variation function is y equals k times x, so my function rule is going to be y equals, I should plug 1/3 in for k, 1/3 x. Okay, so this is all my answer. That's not a J, that's supposed to be a semicolon. My apologies. Make sense? So yes, it's a function rule, my constant is 1/3, and my direct variation equation is y equals 1/3 x. So I want you to determine whether y varies directly with x. If so, find the constant of variation. So remember, you have to remind yourself, what is the direct variation equation? Well, it's y equals k times x, right? Right? Y equals k times x. So what we need to do is see if each of these equations is set up in that form for direct variation, y equals k times x. Here, is it set up in the form of direct variation? Yes, I have y equals k times x. So since it's set up in the direct variation, what is my k? Since it's already in the form y equals k times x, we know that k is equal to 12. Okay? So yes, k is equal to 12. All right, do this second one on your own. Is y equal to 4x plus 1? Does that represent a direct variation? No, it does not. Why? Because we have something being added out here. So remember our equation, there's nothing being added to k times x. It is strictly just y equals k times x. Well, here, I don't have y equals k times x. I have y is equal to some number times x plus 1. So I know this is not a direct variation because there is a number being added to the end of it. Okay, number 4 is this direct variation. First, let's solve for y. The previous two were already solved for y for us, so let's solve for y on this one. So to get y by itself, I add 6x on each side. So then I get y is equal to 6x. Is this direct variation? Yes. Y equals k times x. I have nothing being added to it. So I know that my constant is going to be what? 6. Okay? For this set of problems, it's for the following, y varies directly with x. So I'm telling you that it varies directly with x. So for number 5, it says if y is equal to 6 when x is equal to 2, find x when y is equal to 12. So remember, our y equals k times x equation is our direct variation, y equals kx. Well, here, on this problem, I'm only giving you y and x. I'm not giving you k, right? So I'm giving you y and x here when it's related to the x and y here. So since I'm not giving you k, let's solve for k and get y and x on the same side of my equation in my direct variation equation. So when I solve for k, I divide both sides by x, right? So it cancels out here, and what I'm left with is y over x equals my constant. So in order to solve problems like these, we've dealt with proportions already in this course. So to solve problems like these, let's set up a proportion. So my first proportion, I'm going to have y over x for my original. So what I'm giving you is that if y equals 6 when x is equal to 2, so when I set 6 over 2 is equal to 12 over x. And then I solve for x. Okay, so what I did is I put y equals 6 here. 6 is to 2 as 12 is to x, right? So whenever you solve this, since instead of a proportion, I could cross multiply. And when I cross multiply, I get 6x is equal to 24. Divide both sides by 6, and I get x is equal to 4. Okay, to solve for x, divide both sides by 6, and I get x is equal to 4. Okay, so that's my answer. So if y equals 6 when x equals 2, find x when y is equal to 12. Well, x will have to be 4 for it to vary directly. So number 6, try to do this one on your own. I'm going to work it out on my paper as well. So it tells you that it varies directly with x. I set up in the same form. Y over x is equal to y over x. Okay, so when I solve this one, I get x is equal to 3/5. And then the last one, remember we said that y over x is equal to y over x. So here it wants me to find y when x is equal to 6. So I'm going to put y in my numerator because I remember I have to vary directly. So I keep y over x equal to y over x. So now when I cross multiply, I get 15y is equal to 150. Okay, divides this both sides by 15. I get y is equal to 10. Okay. And then lastly, I ask you to graph each direct variation. Okay, so we haven't talked about the slope-intercept form yet, but when we plug numbers in with our table, using my x and y, okay, I'm going to choose numbers that are going to make it easier for me. I'm going to choose -3, 0, and 3 for my x variables because, as you see, when I multiply -3 times 1/3, I get -1, right? When I multiply 0 times 1/3, I get 0. When I multiply 3 times 1/3, I get 1. When I graph these points over here, -3, -1 is at this point right here. 0, 0 is here. 3, 1 is here. Okay, and then I insert when I connect my dots, this is what my line would look like. Okay, down here, when I use my x and y's, my table, I'm going to choose numbers that make my life easy, so I'm going to do -2, 0, and 2. Okay, -2 times -1/2 is going to give me a +1. 0 times -1/2 is going to give me 0, and then 2 times -1/2 is going to give me a -1. So these points at -2, +1 are here, 0, 0 here, and 2, -1 is here, and then I connect my dots. For my line, I get this line here. Okay, do you notice how both of these lines go straight through the origin? That is what is special with direct variation, is that it crosses at the origin 0, 0 because nothing is being added to it. We'll learn more about slope and the slope-intercept form in the next lesson. Okay, so every direct variation equation passes through 0, 0. That's how you can check yourself. Thanks. Make sure you do your homework tonight.